Okay, so this problem's really got a lot going on, right? Three different parts to it. Let's just read the instructions. Find the perimeter of the figure below. The dimensions are in meters. Remember what perimeter is. It's the distance all the way around the figure. Find the area of the figure, and then see if the figure is the base of a geometric solid whose sides are perpendicular to the base and whose height is 12 meters. Find its volume. So we're told to leave pi as pi, so we don't have to convert that to 3.14 or an even longer decimal number. We can just leave it as pi. So let's see if we can do those pieces real quick. First for A, find the perimeter. Like I said, that's the distance all the way around this figure here. Now what we notice is because we have a semicircle here with a radius of 4, that means the total distance of this right side of the triangle is going to be 8. So I'm just going to put an 8 there so that we will remember that. What about this distance right here? Well, since this is a right triangle, this distance over here on the side that's opposite the right angle, we're going to label that as C, is what we call the hypotenuse. And the hypotenuse, we can calculate the hypotenuse if we have the length of the other two sides using the Pythagorean theorem. So what we remember from the Pythagorean theorem is that a squared plus b squared equals c squared. And so if we have 6 for A, make that squared, plus B, I'm sorry, plus 8 for B, square that, equals C squared, then that means that 36 plus 64, or 100, equals C squared. And so to get the value of C, we take the square root of both sides. And so that tells us that C is equal to 10. So we're going to go ahead and write 10 up here so that we don't forget that on our triangle. And so now we can calculate the perimeter of this figure. There's one other thing that one other formula we have to remember. We have to remember that for a circle, the perimeter actually has a special name called the circumference. And the circumference of a circle is equal to 2 pi times r times the radius. Well, this is not an entire circle. This is half of a circle. So in order to figure this out for our particular circle, we're going to have to divide this by 2. And so the circumference around the perimeter just around this half of a circle is going to be pi r. And so since r is equal to 4, then we can say it's going to be 4 pi. All right, so now we've got the distances all the way around our figure, and we can add those in. So the perimeter of our figure, P, is going to be 6, which is the distance along the bottom of the triangle, plus 10, which is the length of the hypotenuse, plus the circumference around half the circle, which we said was 4 pi. So our final value then is going to be 16 plus 4 pi. Remember, we're told to leave, if we've got a pi, just leave it as pi. So the perimeter is going to have about a length of a value of 16 plus 4 pi meters. So that would be the perimeter. That's our answer for A. For B, we're trying to find the area. And so for the area, we just want to find the area of the triangle and add that to the area of half the circle here. So the area of a triangle, what is that? Area of a triangle is equal to 1/2 base times height. And so that's going to be 1/2 of the base, which is 6, times the height, which is 8. And so that's 1/2 of 48, which is going to be 24. So that's the area of our triangle. And then for the circle, the area of an entire circle is pi r squared. But since this is just half of a circle, it's going to be pi r squared divided by 2. And so the r is 4, so 4 squared is 16. 16 pi is what we have in our numerator divided by 2. And so the area of our half circle is going to be 8 pi. So we just have to add those together to get the total area of our shape. So area is equal to 24 plus 8 pi. And remember, area is going to be whatever your units are squared. So we're going to give that a unit of meters squared. So that's going to be the area, 24 plus 8 pi meters squared. Finally, if we need to find the volume of a figure whose base looks like this shape here, but has sides perpendicular to the base and whose height is 12 meters, all we have to do is in order to find the volume, it's simply the area of the base times whatever the height is that's given. Okay, so in our case, the height is 12, so it's going to be 24 plus 8 pi times the height, which was 12. And so we're going to get 288. That's 24 times 12 plus 8 times 12 is 96. So 96 pi is what we have for the for that number once we distribute the 12 through the whole thing. And volume is going to have a unit of meters cubed. So that would be our final answer. Again, leaving pi as just pi. That would be the final answer for the volume.